Good morning, everybody. 10 o'clock in Germany. Let's start with our last and final episode of the digital web series that WtE is offering here, our web seminars. Today we will talk about waste to energy, waste incineration, and we will look at this tried and proven technology, but show you also ways how we in actual projects around the globe improve them even more with cutting-edge digital solutions. First, the housekeeping, and then I will introduce my colleagues here. You see, it is being recorded here, but just us. So our cameras and what we write in the chat. So Josh, thank you a lot for putting already for the people that they know how to reach you if something is wrong. But that is just what we write. We get your messages. We will reply to them. We will not say your name because of data protection and so on. But it works very well. We have this is the 6th episode of our webinar, so we have kind of experience already. So let us know what your questions are, your comments, and please participate in the polls that we have in between. Also there, we will share the results together, but we will not look at names and so on. So that's it for that. Then I would say hello to my colleagues. Let's start with Joshua. Last time you've been our expert. We talked about the eagle and how to look at the data from a high perspective. If anybody in the audience hasn't seen it yet, you are welcome to go to our website. We have a media there, like a media section, and it is linked there. So that is available. And Josh, thanks a lot for today taking care of our participants for their questions, and make sure if someone has problems, you can take care of that without a problem there. Great. So next is Simon. It's good. It's working. That's very nice. Good to know. Good
morning, everybody.
Yeah. Hi, Simon. So in the past, you've been our social media expert. Today, you are the technical expert as well. You will share your waste to energy experiences there. We have a 3-step presentation here today, even some live demonstrations today. So we will see very, very detailed experiences from the projects. Next in line, Dr. Volker Stephan, head of our development of our PiT systems, APC solutions for cement plants, for waste to energy plants, for different applications. Last time you've been with us showing us how to apply these expert tools even for wind problems, for wind questions there. So there will also be a recording of our last episode soon on our website. So thank you for joining us again. And last but not least, here, Yuri, we are limited to 4 moderator slots. So Yuri has to take the active participant role here today. If you want to see him a little bigger, take your mouse, go over him, and he's enlarged there. But soon when we will share the PowerPoint, we will all have the same size there as well. So thank you, Yuri, for joining us today. Yes, I think that's it. We have the housekeeping, we have the introduction. So let's have a look at the slides. Since it's a little bit of a different topic, I will have a very, very short introduction here, and then we can jump right into the examples and everything. So today, digitalization of thermal waste to energy plants. And it's a proven technology, but we will look how to take it to the next level and how that's used around the globe for many years. Here, one view for you. That's again our map where we have customers around the globe, where we have partners. That was last time our view. And here for today, we compiled the waste to energy numbers there. So more than 2 gigawatts are already using our SRSPC, the module for predictive maintenance that you have seen here. We have more than 30 solutions with our PiT products deployed. That is especially what we will see with Volker pretty soon. And we have done engineering services in waste to energy projects for more than 75 projects, also around the globe. So that's pretty interesting. Let us finish our little overview here. What are STEAG's digital solutions here? For us, it's always a project approach. We combine owner's perspective with operating experiences and cutting-edge digital tools. Since you see our broad field of wind and cement, and they all use the same basis, so we managed to have them highly developed, so they are highly efficient, and we can deliver with our customers together a high value, a high precision for those applications that we have. And those are to maximize waste output, to reduce emissions, to reduce maintenance costs, and avoid unplanned downtime. And that is something we will see with the SPC solution pretty soon. It's not about giving a warning like a minute before something goes bad. It's about giving a warning a week, a month, 2 months in advance when possible, But of course, then it has to be very solid, very precise, so there's not false alarms that people have to take care of. So let us see. To sum it up here, also with a couple of references already here for the waste to energy applications here. Those things that we use for these projects is Epsilon Professional, this tool that we have for designing any kind of thermodynamical cycle about heat balances, about property tables. It's a highly sophisticated solution, and you can even get a test version if you reach out to us afterwards. Next one is the real-time AI-driven predictive analytics module, SRSPC, also with a machine learning module. We will see that pretty soon again here. We have another solution, SIPAM, which is a condition monitoring and maintenance system. So if that is part of the solution that's needed, we also have this to organize what measures are necessary, what needs to be done, when is it necessary to change the oil or filter and so on. That's all part of that module there. Then we look at the APC solutions, PiT Indicator for the complete temperature profile of the combustion chamber, or the PiT Navigator that is able to optimize the furnace capacity control by means of artificial intelligence. And so different of those modules are used in the projects we see on the right-hand side, Kassel, Rosenheim, Mannheim, Simmeringer Heide in Vienna, Ruhleben, Krefeld, Astungshof, Bonn, and Westfor-Branding, I think it's pronounced, and Rosenborg. So you see already like a choice of projects. You can ask questions afterwards. We can have a private talk afterwards if you have specific questions, but this is today to give you an overview and show you what can be done. And if that's a topic for you, reach out and we will have further discussions afterwards. So that's it for the short introduction here. I would now ask Simon now to take over for a little bit and show us a little bit more what we have there, right?
Yes, thank you very much, Dennis, for this nice introduction and the warm words. Welcome as well from my side. I want to start with a solution Dennis talked about at last, about the PiT Navigator for the waste incineration plants. And yes, I want to start with a short introduction. The thermal waste treatment plants operate close to a maximum incineration capacity in Germany and I think in very much countries around the world. Despite high capacity utilization, there is still a potential that can be exploited, for example, through the use of artificial intelligence for combustion optimization. With the following slides and in the following minutes, I want to describe the components and the functionality of our modular system and concept for a AI-based combustion control for thermal waste treatment plants. And yes, before I get into the technical details of the system, however, I would like to approach the whole thing a little different today and start by telling you a few facts about the product that has been successfully placed on the market for many, many years. So you can see it on this slides. The system has been in use for many years in many plants, both nationally and international. STEAG has more than 15 combustion optimization systems and more than 30 video and thermography systems for burnout and fire end line control delivered and successful implemented. So far, the projects are spread across the European countries of Germany, the Netherlands, Spain, and Denmark. But of course, I have to say that we are not focused on a specific country, and we are very happy to expand our waste horizon, maybe with you together.
Simon, I like the idea to start here with the achieved goals. I think that's a good point to see what comes out when everything works successfully. But what are the parts of that? What are the measures? What are the modules? Could you also share a little bit like how you get there?
Yes. Yes. Let me jump onto the next slide to answer this question. you can have a look on this slide. You can find here 4 major blocks of the system that all work hand in hand and interact with each other. Let's start with the block on the left upper side. It's the APC. The APC enables economically optimal process control. For example, several target variables that need to be controlled and that influence each other, such as a steam output, combustion temperature, can be adjusted simultaneously by a number of influencing variables such as air volume, air temperature, or, for example, grade speed. With the integrated optimizer in this module, these settings can also be made in such a way that they are made under optimum parameters while simultaneously taking into account all technical boundary conditions. On the right upper side, we have the prognosis models, which are based on artificial intelligence. Depending on the objective of the control system and the design of the waste incineration plant, there are prediction models created for important target variables. They use neural networks trained on the basis of plant process data to forecast the value of a target variable approximately several minutes in advance. So that's very important because such a forecast, for example, of the steam output enables downstream controllers to react with appropriate manipulated variables even before a steam peak occurs in order to minimize deviation of the generated steam quantity from the target value. The third big block is the experience of the operating staff, and this is for us very important. The user has the possibility to adapt the behavior of the system and important parameters to operational requirements. So important and frequently used target variables such as a steam set point are taken directly from the plant's process control system. Other relevant process variables like, for example, the grade trim or air distribution of primary or secondary air, etc., can be manually influenced by the plant's operator at any time. The operator can also enter into the system, and for us, very important variable that is difficult or I think mostly nearly impossible to measure, and this is the quality of the waste or the calorific value of the waste. But more details will follow shortly from my colleague Volker with a demo system. The last but not least block is PiT multisensor. It is a furnace camera with powerful software behind, and the firebox camera is mounted above the slag discharge so that the optical sensors view extend from the end of the grate to the waste fire. And the system provides video images and thermographic information that is transmitted to the control room to detect both the final position of the main fire zone, it is called the fire end line, and problems with unburned waste at the grate end. These information about the fire position and burnout is then used for control to respond by adjusting manipulated variables such as the primary air or the grade speed. And this ensures that the fire is kept in a, let's say, stable position with good burnout at all times. And yes, depending on the type of the plant and the tasks to be carried out, additional information, for example, the left-right inclination, the intensity of the fire, etc., can also be extracted from the image and transferred to the control system. And with the next 2 slides, I want to show you just short the two ways of pictures. You can see on the right side of the slide a temperature profile which is set by the PiT multisensor, you can have a close look, and you can see, yes, what temperature do you have in which area of your grate. And the other picture just shows the with a dotted line, the calculated and the detected fire end line position. And all these information which we get from this multi-sensor does directly go into the system and takes account in the controlling of the system.
Simon, one question from my side. I can see a couple of managers from waste to energy plants connected here as well. Often I hear that cybersecurity is a huge issue for them. How would such a system work? Is it like fully cloud-based, or is there a danger for current cyber attacks or whatever? Do you have a word about that as well?
Yes, this is a good question. The system runs on its own server hardware with a standard interface to the DCS. And yes, so the DCS is not stressed by the yes, really CPU intensive artificial intelligence tasks and the calculations of the AI. And at the same time, it is shielded against cyber attacks from outside. So this is no problem for our system that the managers need to
So like worst case, if our system would be gone for any reason, do they have to shut down their plant?
no, this is no thing our system occurs. So if our system has a problem, or if our server going into the shut down, the plant can run by its own, and
Just
yes,
without the optimization like before.
manually.
Yeah,
Yes.
that's good.
Yes.
Thanks a lot for clarifying.
Yes, let's go back to the slide which I show you. The entire system is based on a modular way. The basis APC module for controlling, you can find it in this bubble here, a wide range of actuators, and the AI-based steam prognosis are mandatory. So we really need these two modules. The steam prognosis must include at least one neural prognosis model for steam output or other target variables, and in addition, other modules, other prognosis models, for example, for the CO variable or NOx, etc., can be created and activated as well. With a module plausibility check, the user informs the system whether a critical measurement is relevant or not, which is necessary, for example, if a measuring device is being serviced or is defective. The system performs to check independently as far as possible. However, the user can simply override the decision by means of a little checkbox. And with the module, like we call it, individual activation of actuating variables, long word, it is possible to move a specific actuator manually while the navigator continues to control the other actuators. But I think Volker will talk about it later with the demo system. Yes.
I think that gives a nice overview. Soon we could maybe have a look also how that as an actual project looks. I think that will be more concrete then for the audience. But please finish up wherever we are right now. I didn't want to interrupt. Just I think a project view is also pretty helpful soon.
Yes, of course. Maybe as an example, I can short describe a project of one installation at a waste incineration plant with an annual throughput of I think nearly 250,000 tons per year. And the system solution was introduced in close cooperation with the plant team consisting of process engineers, IT engineers, as well as plant operators, and as well experts from STEAG. And this ensured that the personal experience of the operating personnel was also incorporated in the new furnace optimization from the beginning. And yes, after a first STEAG in-house of the system, several days of on-site commissioning followed. And after the successful commissioning and optimization phase, during which the system further adjusted in terms of its accuracy. And in the actual project, a 4-week comparison run was carried out. I will show you the results of this comparison run with this slide and the table. Yes, in the actual in most cases, one of the key process parameters is the steam output of the incineration plant, which in turn allows conclusion to be drawn about the throughput. In this special project presented, the standard deviation steam could be reduced nearly 50%. So it means the half of the standard deviation. And the associated increase in steam average is also very significant by means of more than 3%. And furthermore, the reduction of emission peaks are not to be underestimated. Here, the average values of CO and NOx in the exhaust gas could be reduced. And this positive effect is of great importance, especially with regard to the compliance with the emission limits. And yes, probably the most interesting and important parameter, however, is the average of the waste throughput, which has a direct influence on the profitability of the plants. And there's an increase in the average waste throughput of more than 3%. You can find it here on the right side, caused by the AI-based furnace optimization could be analyzed. And this leads to at the end, to a return of invest of significantly less than 2 years, which is very, very good. And now we would like to give you a little deeper insight into the usage concept of the system by means of our demo system. And I think I would, yeah, it's Volker's turn or Dennis' turn maybe.
Very good. Yeah. Just to summarize, I heard again many times, like together with the people on site that have the knowledge. Yeah, this is something. Together it's set up. The AI is helping, but still the operators are in charge. They can still override the system. I think that shows what we've seen the last half of a year. This partnership approach to the problem and to solve it together. So that's impressive. So maybe we can also see that now in the system that we can have a look at. So Volker, it's your turn now. Maybe you can share really how that looks, how that feels. And yeah, I'm very curious to see that live now.
Okay, I will try. Please give me a second to share my screen.
Absolutely.
I hope you can see it right now.
Looking good.
Yes, what you see in this screen is more or less the human-machine interface our system is offering to the operators. At the first glance, you see the core of the waste-to-incineration plant. You see the grades, you see the first and the second pass. And in the top left, I don't know, can you see my mouse cursor?
It works.
That's great. In the top left, where my mouse is to be seen right now, the operators usually get some basic status information about the system. The first point is, for instance, whether or not the connection to the DCS is working well. There was already a question about this. Of course, this is very important that the interfacing between our system and the DCS is working nicely, because otherwise strange things might happen. But this is monitored and observed all the time. And if something behaves strangely, we automatically switch off and alarm the operator. So there's no need to be afraid of some malfunction if the connection goes wrong. And the second point is about the camera, if this interfacing to our camera is working properly. And then you see that the system is ready at the moment. That means the operator may switch on our system. It is ready to take over control of the plant. And then the last line, it shows that our system is currently really online. So beneath these status information, you also see the main or the most important parameters of your plant. You see, for instance, in this area, the current main steam flow, its measured value and the set point. You see the emissions at the end of the boiler, the oxygen, and you may also see other values like CO and NOx, depending on its configuration. On the bottom right, you see the current picture of the rear camera. The rear camera, it is located at the back side of the boiler and showing the perspective from the fire moving towards the de-ashing system. You see also the current values of the typical actuators, like the amount of waste which is pushed into the firing zone. You see the amount of total primary air, the grade speed, the fire length calculated by our camera, as Simon already described, and also the secondary airflow. In the bottom left, you have a short diagram showing the most important features or variables of the plant. You see, for instance, this is the main steam flow, its set point. You see the waste flow. So this is the page the operator usually has or gets a very quick overview about the performance and the status of the plant and our PiT Navigator solution.
Volker, maybe one question in between, as we can see the picture of the camera currently here. There is one question regarding if we have to shut down the plant while installing the PiT Navigator. So we put the camera in the burner, is it right? And does the plant have to shut down, and for how long to install the PiT Navigator?
Sorry, I did not get the question. Your question is, in case the operators wants to shut down the plant, what do they have to do with this camera? Is this your question?
How do we install the PiT Navigator? Does the plant has to shut down for a longer time period? Do we require an overhaul or a longer time period to install the system, or can it be directly put into operation?
It depends. Of course, we need an opening at the position where the camera needs to be installed. Some plants already have openings, be it in some small doors used for revision, and some plants also want to have a dedicated opening for the camera. In this case, it may be required that they do some tube bendings for this, but this always depends on the situation. And in most installations we have done in the past, the mechanical adjustments are usually done during a short outage of the plant.
But this is only for the camera system. For the PiT Navigator system, there's no shutdown of the plant required, so we can do it while normal operation.
Yes.
Are we talking about a special PiT camera here, or can also be existing cameras be used that might be already there?
No, we are talking about our specific multi-sensor, so our camera, because it's not only the camera image we use. As Simon already mentioned, we can also calculate some temperature distributions across the fire area. So we need our special camera for this purpose.
Okay. And maybe now it's time also for the audience for the first question here. First of all, I would like to say it looks pretty tidy. It looks pretty organized. Yeah, and I have seen many DCS screens which are pretty full most of the time, and something is always blinking. Yeah, look at me, look at me. This looks very nice. So I see the difference there between this expert system running next to it and the DCS that is ensuring the operation and everything. So that is my first impression here. Now let's have a quick question, because I think with such a system and with setup strategies and clear numbers and maybe even calculated numbers on the screen, I would assume that it's easier to have the same efficiency over all the shifts, and not one shift does it this way and the other one has a completely different approach. So instead of asking only Volker, I would like to ask everybody now. Let's have it here. do you see changes in the behavior caused by different shifts? We moderators cannot even vote, so it's very safe here, our election system. So currently answers come in. Even if you don't own a plant, but you have a feeling what the answer is, you can also participate here. Yes, we are pretty clear. It looks like nothing is happening, but a couple of votes, and so far one answer is only coming in. So I will finish now. Thank you for participating, and you will be surprised. Okay, here we go. I would say it's a pretty
100%.
clear picture. Yeah, yeah. I mean, it's pretty clear, but yeah. Let's see what else. Yeah, the other one I think we will save a little bit for. Oh no! Since we are also active right now, everybody's on the keyboard. Let me ask another question here. This one is about if you have the ash, do you sometimes think there is a need to discard amounts because the quality is not good? Yeah? Unburned CO in the ash and so on. Do you have a feeling about that? So one thing was the shift. That was the first question. Now the question: do you think there's often the need to dispose of the ash which you could use, you can sell otherwise? So answers are coming in, but I think that is already more complicated than the first question. 2, 3. Oh, but again, pretty clear. Great. Yeah, let's finish here. Thank you very much. And that's again how it looks. Amazing. Good. So that was a short interruption here. Let us go back to this to Volker more or less. You might have to reshare, Volker. I think I just kicked you out of there from the screen sharing. Sorry, but I think that's a clear picture. And yeah, how does that reflect? Yes, we are back.
Looks good. Yes.
Okay. To give you a feeling how the handling of the system looks like, I would like to show you some examples. You see on the screen there are a couple of links. These are these gray boxes, because usually the operation of a waste to energy plant is not simply switching on and keep it running for weeks. From time to time, you have to adjust something. For instance, one key parameter which will see adjustments is the main steam flow. At the moment, the plant has a set point of 40 tons per hour. You see the measured value is also quite close to it. But it happens usually that for some reason, the plant operators want to change the set point. So a typical case would be that we get the set point from the DCS directly. So whatever happens in the background in the DCS, our system simply takes over the DCS set point and tries to follow it. But to give you an example how the handling for the operator could be, I just followed this link, and then you have a couple of settings the operator might change. There is, for instance, this box. It's about the target set point for the main steam flow. You see the current setting is 40 tons per hour. And by clicking on this symbol, a new dialog appears. And now it's up to the operator to adjust the new set point. He can use this slide bar, or he can also enter a number, whatever he wants. Clicking OK. And a few seconds later, you will see that this set point of the main steam flow, which is the bright or the thick red line, it jumps from 40 to 41. And I hope a few seconds later, also the measured steam flow starts rising to reach this new set point. Beneath the set point, the operators can also adjust some minimum and maximum values. And this is not only for the main steam. We have also the same setting for the oxygen. That means at the moment the set point is at 5%, but he could adjust it easily in the same way as we have seen before for the main steam flow.
What we can't see here is the window where we can insert the values, but it will be there.
Sorry, what did you miss?
Yeah.
it only shares the overview here,
Yeah.
but there will be for all those who this presentation here. There will be a small, you can insert your
Another
set
short
points.
hiccup here. I think it's fine. I mean, there's a way to put in some manual values. We can show that if somebody is interested, show it in more detail later on, but thanks for adding. Yeah, if something is not matching what Volker sees, this is just because the screen sharing here is kind of limited.
Okay.
But I hope everybody's back. If not, hit F5 to make sure everybody's coming back. I might do the same. Now it looks, oh yeah, funny. I can see Josh moving on the other computer. I'll be right back.
I'm here, yes.
Okay. And another example, which is quite common in some plants, is it sometimes happens that the operators, for some reason, want to run an actuator by hand. Be it because they have to do some maintenance work on these actuators, and usually they don't want to switch off the whole control system. They just want to set one specific actuator to a specific value, keep it there for a few minutes, and then give it back to the PiT Navigator. So how this can be done, I can show you based on the feeder. If the operator wants to act the feeder in manual mode, then he can just follow this link, actuator page, and then he can get, yes?
We can see it.
Okay, then he gets this diagram where he can simply see how the feeder was run in the past minutes. This is the thick black line. These dashed lines are the upper and the lower limits, where the operator, for instance, can say for the control, please run this feeder always between 33 tons per hour and up to 40 tons. And if he wants to run it, let's say at the moment at 34 tons per hour, then he just enters this number here for this operator set point and activates this hand mode simply by clicking on this button. And you see what happens is a few seconds after the current feeder speed jumps to this level the operator wanted to have, and the remaining system still keeps online. You see the navigator module is still online. All the other actuators are following the controls. Only the actuator is running in manual mode, and this is also displayed in this orange color here. So the operator can see at the first glance that all the actuators are in automatic mode, except the feeder. This is running in manual mode.
Yeah. So since we had a small hiccup before, so those that cannot hear should just refresh their browser window. We should be good here. I think I can hear you all. One more comment here, since we have many of those optimization systems for different applications. Sometimes I hear, they are often turned off since they're not totally satisfactory in the real world. Since how it was set up, maybe one value is limited right now, but I think it's pretty convincing here to me. If you're not happy with the full auto mode, you can just put in some manual things, because you might have a good reason and still use the optimization to benefit anyways, even though you don't have the flexibility for everything at the same time. So I think that's a good compromise. Good.
And if the operator wants to give back feeder control to the automatic system, then he just follows the same procedure, just backwards. Go to this screen, deactivate the hand mode, and that's it. You see automatically the control system takes over control over the feeder speed and jumps back to a higher level. I guess because the steam flow was a little bit below the set point, yes. So that's all you have to do for this case. And there's one other example which is showing how the operators can be integrated into our system, because for some measurements the operator still has some advantage over our system, especially if it comes to the composition or the quality of the waste, because the operators, either they run the cranes feeding the feeder itself, or they at least have a view what type of waste is put into the into the feeding system. And based on the experience and the knowledge of the operator, it is sometimes helpful to get this experience into our system. And this can be done by, for instance, these 3 buttons you can see here. This is a selector where the operator can say what he thinks, what the calorific value of the waste right now is. And if he, for instance, sees that the next bunch of waste is of quite low quality, of low calorific value, then he can simply tell our system this in a way that he activates this low CV waste button. You will see right now nothing in this control because this usually takes some time until it shows some effects. But this is a very easy and handy way for the operator to tell our system some information only the operator has. So, and in this way, we
Can
can...
you still hear us?
Yes, can you hear me?
We hear you. Yes, everything
Okay.
works right now.
This way, we can integrate the operator's experience into our system.
Good. Yeah, very good. I mean, that was an interesting view. I think there's much more behind, but we should maybe keep that for another webinar. So if there's lots of interest, let us know afterwards, or just schedule a private meeting with us and we can go into more detail to really find out how that could help you in your daily plant operation. So maybe we can now switch from optimizing the moment. Yes, right now we have an optimization to a long-term view. So we said in the beginning, we have the predictive maintenance approach that gives weeks and months of warning time ahead something is really happening. So if I could ask Simon now to quickly share a little bit of our AI-driven predictive maintenance, like it's a small break here right now. We finished the PiT topic for a moment. We switched to another module for a moment, just for everybody to make sure that it's not the same, but we can really find out when what makes most sense, and sometimes even both modules might make sense, but that should always depend on the actual project, on the actual conditions and the savings and so on. So we are there to help you to find out what makes most sense, what has a good ROI, what is really solving those problems that give you a headache. So Simon, please share with us the AI-driven predictive analytics a little bit. Thanks.
Yes, thank you, Dennis. Let's add the proven technology, the AI-driven predictive analytics or predictive maintenance. As power plants and their components are subject to continuous changes in their operating behavior, Dennis told before. And these regularly lead to undetected degradations of the plant efficiency and to what appear to be sudden failures of components with a significant impact on the sustainable and economically efficient operation. And the SR APC system is a very clever system and can analyze the most important data on processes and main components out of the vast amount of data from the DCS, so that slowly creeping and critical changes are detected safely and early on. And as an early warning system, the SPC uses tried and tested modeling techniques for determining reference values. And before my colleague Yuri introduces you to the AI behind the system in more detail, and then presents our successful large-scale project and some success stories, I would like to tell you about the benefits of the system.
Since more messages come in, maybe we should take a little group activity here right now. Everybody should, who has problems, who has like a noise or whatever issue you might have, hit F5 or just reopen this tab here. I just copied the URL and just open a new browser tab. Sorry for the inconvenience, but maybe that's a good break here, a little exercise for energy. See, I'm trying to make the best out of that. And I hope when everybody can hear us again, I mean, I had to refresh, but here it's good right now. I can hear everybody, I can see everybody. So hopefully this is fine. And okay, so now please go on. Simon, sorry.
No problem, you're welcome. Yes, let's come back to the key objective of this digital solution. And this is the key objective to unlock economic potential through real-time health and performance monitoring. The system enables early and reliable detection of anomalies in real time. If an unusual or deviating condition is detected, the system issues an alarm. And in addition, an overview of the assets and components' health condition and performance can be shown. Since particularly creeping processes, like I told you before, remain undetected by the operating personnel, special attention is also paid at this creeping processes. The automated and continuous AI-driven prediction of trends offers real added value here, I think. The entire system is browser-based, and the user interface provides an optimal overview and is supporting decision making and knowledge transfer. And if you have a look on the right side of this slide, you can see just one or two examples of this user interface. But the system offers much more in the visualization than this small picture suggests. So I want to show you the next slide, our user-friendly data visualization. And as we deliver the system, the SR-SPC system, with a visualization SR viewport. And here you have an extensive dashboard with the most diverse information at your disposal. In addition to the performance parameters of your entire plant and individual components, the anomalies detected at an early stage can be displayed and shown in real time. The visualization is also available for your benchmarking purposes. So here you can generate monthly extraordinary reports, and this fully automatically and AI supported. And yes, the SR viewport is available for smartphones and tablets, and yes, for Android or as well for iOS systems. Yes, before we get into the technical details, I would like to briefly summarize the benefits with this short slide. Yes, you get a comprehensive overview and transparency through processed data and derived KPIs. The system allows you to early detect and detect inefficiencies and damaged infrastructure. And this helps to avoid consequential damage as well as unplanned shutdowns, which are really cost intensive. Rather, you, as the operator of the plant, are given the opportunity to plan necessary maintenance work early and sufficiently. And in addition, you will be able to address the supply of spare parts at an early stage and thus avoid supply chain problems. And all in all, the system ensures significantly improved availability and efficiency of your plant, which pays off monetarily in the end. And for this reason, I can say, or I think we can say, that SR-SPC helps you to reduce your OPEX and increase your energy revenues. And now I think I have spoken enough about the advantages of the system and benefits, and it's time to show this also on a technical level.
Right. Let's first have a quick poll here to see how severe the situation is. It's not only supposed to save OPEX, it's also supposed to save headache. What is a big headache? Yeah, if you have a couple of outages over the year, and then everything is good, and you still have a shutdown and an emergency shutdown when the prices are good, when you have the trucks in front of your gate that want to deliver the garbage and so on. That is a headache situation. So let's ask the audience pretty quick. How many unplanned outages do you think are typical there? So outages, yeah, if they're planned, it's fine, but unplanned is a headache factor. So let's big start here. And some extra points for everybody who sees a pattern in the numbers. You can let us know in the chat, and you might get a little present. Good. So yeah, answers are coming in. It all looks like the 0 is not so popular here, which I think shows that the audience is pretty specialized here in the industry and knows what's going on. Let's finish this little summary here. I hope everybody had enough time. Let's look at the results. 50-50. Here we go. So half of those that voted here have like more than 4, less than 8 outages per year. And those with the green color have between 2 and 4. So unplanned ones. So I think that is worth looking for that, and depending on the calculations there, even avoiding one big bad outage that was not planned is already paying for the whole effort, for the whole SPC project and everything. So let's have a talk. If that is something that's bugging you, let's have a talk and find out afterwards if that is possible to help you there. Good. So now it's up to Yuri. We have to click for you. Once again, if you want to see him a little bigger, just use your mouse and put them on the little screen, and Yuri is twice the size. And yes, Yuri, share with us how that looks in the real world, please.
All right. So you can hear me loud and clear?
Yes.
I hope
yes.
so. Great. So first question from my side. We have 7 minutes left. Do we have an add-on time?
Yeah, we will today give a little extra and just I don't know, another 10 minutes or whatever. If you're in a hurry from the audience, you can later look at the recording to finish up. But we shouldn't rush. I think that's important content that you prepared, so we'll take some extra time. So thanks for asking. Good. Very nice.
Okay, good. So I will start where the other slide ends and give a brief overview about the technical our technical approach in regards to AI predictive maintenance. Since the tool was, or the technical issues were presented in the other workshop more in detail, so I give you just a brief introduction. So the major problem is number one, to avoid downtimes in the waste to energy sector, and secondly, the performance, maximizing the performance. So to avoid unplanned downtimes, you have to monitor and get a closer look into the critical assets of a power plant. And our tool give you the technical improvement to do that. So basically, here is an example, is a bearing temperature, which is, if you look in detail and focus on the yellow line, this is the average bearing temperature, which is increasing steadily until it reached the alarm limits of the DCS. And usually, if you don't have an additional tool, exactly at that point, you get a notification, the alarm, and you have actually no additional time to maybe react to order spare parts and something like that. So at that point, it's usually that you get to the point of unplanned downtimes. And we try, and we give with our tools our customers the possibility to get an early warning by close monitoring such key component, and as you see here in the slide, give an early warning at the first yellow dot here to give you time to check the issue, to give you time to check your spare parts and plan the maintenance tasks accordingly to this warning. Okay.
Would you have a rough number how much this yellow dot is coming before the red dot? Is it days, weeks, months, years? decades?
No, it's usually it's of course depending on what kind of asset we are monitoring here in the bearing sector. It can be months before. So you have get a notification. You can check, okay, and monitor it more closely. So that's a wake up call at that point, very early, and then you're monitoring more closely in the next weeks, months, and if the damage is not increasing, you have time to plan and maintenance task check during the next shutdown or major overhaul, right?
That's good.
But you get the first wake-up call, and not
Good.
as soon as the limits are reached, right? That's the benefit of our system.
You want to go to the next slide?
Yes, next
I will
slide,
click.
please.
Yes.
And to get this early warning, we are actually creating a digital twin of each measurement or asset to in a good condition, so that we are enable the customer to monitor online the condition of the bearing temperature or delta pressure of a flue gas system. It depends on the asset which we are monitoring. So by creating this digital twin with our tool, and we have then the reference value for the specific asset or measurement, and by comparing the current sensor-based data with our reference, we enable the customer to detect anomalies. So in changes of the behavior of the measurement or the asset, we enable the customer to detect these anomalies in an early stage, and of course try to avoid false alarms by using very specific statistical methods on top.
Maybe we can use the next example here of one of the projects that you are involved. But anomaly is pretty broad. It could mean purely data science. You have no knowledge of what's going on there. But I think in our case, in your case, it's different. You're coming from an engineering perspective, right? So let's have a look here how that actually looks, and how engineering related those anomalies are, and pretty technical already.
Yeah, of course. So basically how we get to our reference value is we're using the raw process data, and with an AI learning process we create this digital twin, as I mentioned before, in a healthy, in a good condition, right? So we have each time, and for each point in time, also in the future, we have a reference of this specific measurement, this specific asset in a good condition, and can compare the current condition with this reference, creating a so-called key performance indicator, which is load independent. So it's basically an ideal indicator. And as soon as this indicator deviates from this normal behavior, we are able to identify these changes in this behavior and give a notification as soon as a critical level is reached. So basically you see in the below, so in the first diagram, you see our KPI, which is creating by comparing the current situation with our reference. You see the KPI is still very noisy and is volatile, and might give us also false alarms. But on top of this KPI, we, as I mentioned before, take a step and give a significance check. So we add statistical methods to identify long-term changes and minimize with the statistical methods also the noise of our KPI, and give reliable alarms as soon as a critical change or an anomaly is detected. And at that point, we are also able to give a prediction as soon as a critical level is reached. So, for example, if the bearing temperature increases steadily over next weeks with a degree of 10, so increasing with 10, so we can say in 3 weeks you are reaching possibly a critical level here. Yeah.
So Yuri,
projection.
maybe that fits perfectly into one of our questions. From your experience, how early can we detect that something is changing in the plant, or from some data analysis, how much time can we see? How early can SPC warn before something happens?
So usually it's weeks or months. So as I mentioned before, we it's really depending on what we are monitoring and how critical this measurement or the asset is, and how sensitive we create or the customer creates the notification or the alerting. But usually it's weeks or months in advance. So of course, at that point, you are enabled now to check the issue. You can reduce, or you can take action on that alarm, and you can of course avoid further increase of this damage, and extend the lifetime until the next major overhaul. Yeah. So these are the benefits what we can provide with this tool.
So yes, I think we can go to the next slide, Yuri,
Yes.
to the
Yes.
large scale project.
Yeah, of course. So
MEV.
in the waste energy sector, in 2018 we get our first big customer, the pioneer in this sector, MVV, with a yearly consumption of 2.4 million tons of waste, and basically is using waste biomass or methane fire plants. This customer, after a first pilot project in Mannheim, decides to use this tool for all other plants. So there are 30 sites in total, and 7 are already using our tool. And with this fast-growing team, they are currently there are 850 KPIs currently monitoring the 7 sites, and it's still, of course, growing. We are currently implementing the next 5 units or sites. And if you go to the next slide, there's a timeline of this successful project. So after, as I said, Mannheim, 2018, 2019, a 6-month period of evaluation phase was successfully done, and the customer decides to roll out our system on all other sites. And we started then first in Germany to implement the tool in all biomass, waste energy plants. So in Germany, after that, in 2021, there was the first pilot project in the UK. So 2021, we are finally finished with the full implementation in Germany, and we go now to the United Kingdom and implement the tool on these plans.
Yuri, if I understand right, if you say we are doing that, that's you, our colleagues, but also the customers, experts together. Is that right?
Yeah, that's right. So in the evaluation phase, there were of course, we start the implementation on site. We train the staff. And by we, I mean Stärk Energy Services. Implements first. We train the staff from MVV, and after this training, the customer will be enabled to create their own KPIs. So we in front end, basically we give base configuration with around about 30 KPIs for waste to energy, usual KPIs, which we also created with during the training and workshop with the customer together. And after that, as I said, they have over 850 KPIs currently running. And the customer is able, after this training and workshop, to create their own KPIs and monitoring on yourself. What I mean with the full implementation, and so I'm going there for each new site. I implement the interface, I implement or install the software, and after that there is a takeover and the customer creates the KPIs on itself. Of course, there is additional service, but around about 99% of the KPIs are made by the customer. Yeah.
So one more question for understanding. 850 KPIs sounds like a lot, but I assume there's a couple of similar ones, simple ones, but maybe also a couple of super complicated ones that took a while of discussing and trying out. Is it right?
Yeah, it's like I think 50%. So we have also a machine learning approach with our tool. So usually the customer starts in a new project with a machine learning approach. So the KPIs are the KPI creation is done by our system and not like supervised by the engineers of our customer. And currently, I think it's about 50 to 50%. 50% is high quality supervised KPIs, very sophisticated, and 50% are like AI driven.
Good.
Created KPIs, right? Okay, so we can go to the next slide to the examples.
Maybe we can pick one example for now. We can save other ones for another webinar, or if somebody is super interested, let us know. We can have a private meeting, and then maybe in 5 minutes we can wrap up here, since we are running out of time a bit there.
So a major problem in waste to energy plants is the fouling of the flue gas path, right? And this should be in periods there is a cleaning process to avoid the high delta pressure in the flue gas path. So the timing of the blast is very, very critical, and to also after the cleaning process to check if everything is now running on the normal conditions or not. So without our system, there was, like you see in the circle, there is if the cleaning process is not sufficiently done, there is a memory effect. So the folding process is still not, or the flue gas path is not clean enough. So it's the after the first, you see the first drop, it's not going back to the normal value 1. So it's still critical, and it's still red from our perspective, and it means that the cleaning process was not 100% sufficient, and there is still falling in the flue gas path. All right. And as soon as the critical delta pressure is reached, the plant has to shut down and do a manual cleaning, not a blast cleaning, right? So this takes a long, it's a long period of downtime, and usually the power plants try to avoid it as long as possible. So, but as soon as our system was implemented, you see this memory effect was not longer there. The customer was able to time the cleaning process very regular and very precise, based on our alarm system here. So this was implemented since August 2018, since the project evaluation phase starts. Right. Okay, this is one example, and if you I can just quickly add something on it, and another method would be to monitor the cooling of the flue gas system by using also the temperature of the flue gas system, right? Or flue gas. Actually, it's also an indication of the fouling process. So you have two you can combine these, or you can it depends on the design of the flue gas path of the boiler system, which measurement is at which stage of fouling is much more useful to time the cleaning process. So also you can use the temperature measurement to decide when you should clean the process. And you see also here in these alarms, you get an early alarm, and you have time to decide when you're timing your cleaning. And usually it's 1 week, 2 weeks, 3 weeks, depends on the fouling process. You can see it here in this chart.
And here it looks so simple, just the Shewhart X-bar chart, and that's it. But of course, in the cockpit, you have already, what we saw in the previous webinars, many different views already prepared up until the raw data that is shown there. Plus, it's fully, as you said, we give the training to the customer. They get the full access to the studio, where they can see different views, XY charts, and so on, to really deeply analyze what's going on there. So this is just the tip of the iceberg, but it shows pretty nicely what can be achieved there. And as you said, you just wait for an email as a wake-up call, and then you get active to see what's going on, knowing that you have weeks in advance, and it's not time for a panic attack yet. Great.
Exactly. And this Shewhart chart is, of course, like you said, tip of the iceberg. If you in a DCS, you see also just the raw data, and this data is very load dependent, operational mode dependent, environmental dependent, and you are not able to identify if the temperature is now critical, reach a critical level or not, very easily. And this tool is, as you can see here, identifies the criticality very precise.
Okay, so maybe now it's time for a super quick wrap up here. I think we've seen different solutions today to improve waste to energy plants, either with the PiT Navigator to improve the actual performance right now, or here with the SPC for having the long-term effects, a very high quality of looking at the data that's already there and getting a wake-up call weeks in advance. So that was pretty impressive. I know there's much more to tell, so if you're interested, let us know. Also, we will take some of those stories and some of those case studies here with us for the Energy Week in November. I would like to quickly share the link here with you. And of course, here's Simon's contact data for all the waste to energy topics. You can just reach out to him and he will take care of all your questions. I will share the link here on our LinkedIn page, and I will Energy Week in November, second week of November, 4 days, each day 4 presentations we will share STEAG wide, even with customers around the globe, from China, from Thailand. We have customers that are joining us there to look at their projects, their experiences, what went good in those projects, what is maybe something to best practice learning in the future. You will see STEAG experts sharing experiences. This will not be a sales pitch there. It will be looking together at those questions that are affecting all of us, and from the decentralization to decarbonization or digitalization, that will all be covered there. We are currently working on finishing the schedule, and if you follow us, we will see that, and you have a possibility to join us. And we are currently preparing us to be in Essen on a little stage, unfortunately without a big audience this year. You might understand why that is a little hard to plan these days, but we will be there, and you can join from wherever you are, and it would be great to see you there again. Thanks a lot for joining today. Thanks a lot for the questions that Joshua was able to pitch in here on the go, so we don't have a big list of open points remaining. I would really like to invite you to send any feedback to me, to Joshua. It's all helpful. Either it was good, it was bad, whatever. Just let us know, and we will consider that for the future. And so that was the last episode of the first season of our web seminars. I must say we did a lot of learning here on the way. So now I'm happy we can use that all for the Energy Week. And yes, let's stay connected. Let's stay in touch. If you have questions, ideas, let us know. And if you want to reach out to any of my colleagues, they are happy to hear from you as well. So goodbye. Have a good rest of the day. And I'm really hoping to see you soon again somewhere. And if possible, in person would be best. But also digital is also good. So bye-bye. I don't know. Anything else?
Yes, no. Thank you. Thank you for joining us today.
Bye, everyone.
Thank you. Goodbye.
Bye.
Yes.